Hi everyone, Mulkik with you. Today I'm gonna talk about linear algebra, specifically reduced row echelon form, and they called it RREF. So instead of calling reduced row echelon form, I will only say RREF. It's like here, I say only RREF. And it's very abstract topic, and I will call this as artery. It's like our blood artery of linear algebra. It's a very important topic. Linear algebra. It's very important topic. This one, and you know it's linear algebra. Linear is only like a line, and matrix has a lot of equation which describe a lot of line in the xy plane. So it's not, if it's non-linear, it will be hard to solve it by solving like statics or anything to solve it. But here it's only linear, so it should be easy, and of course easy operation to do it. Here it's like here true false, and the green are in all in green are in RREF, so I will write RREF, all in RREF. It's good for true false if you have it in the linear algebra course. And here the yellow one are not RREF, are not in RREF. Okay, so we have to follow steps here. If they satisfy its mean, they are in RREF. The first step, put the first element in the matrix leading equal to 1. So the matrix leading, it's like here, it's 1. I will explain it more later. Here the second one, put the rest of the column equal to zeros. So for example, here the first one, the leading one here, it's the leading one here, the first one, it's, and the rest of this one equal to 0. This is the leading one, the rest of this one equals 0. This means this step, and I have to write the third one, go below the leading one, and this mean and go right to put leading one. And this step I will write as a condition, there there is no non-zero element below it. Below it. Okay, so I have to close this bracket. Okay, so here it's like a game. Here you have to imagine here like 1 here, you go to below this one, go below, then go and go right until you find 1, this one, below, then go right until you find 1, below, then go right until you find 1. It's very easy. And of course, if it's leading 1, this leading 1, these are leading 1, below and above it should be 0, like this, it should be 0. Here the same thing, imagine here like 1, go below it, then go right until you find 1, so this is the leading 1, go below it exactly, and keep going until you find 1. And remember this one, there is no non-zero element below it when you are searching. So when I'm searching here, when I'm going to find the leading 1, there is no element below it, below I'm searching, which equal to 0, which is non-zero element. Oh, keep in mind this condition here. And here the same thing, imagine here like 1, go down and keep going until you find 1, down and keep going until you find 1. This, all of these matrices satisfy this condition. Again here, imagine here like 1, go below, then keep going until you find 1. This is the one. And of course below it, it's equal to 0. 1, go below it, then until you find 1. Below it and keep going until you find 1. Go below it and keep going. See this above of this one, it's fine. If it's below, it's not fine. So keep going until you find 1. Of course, later next video I will tell you how, if it's not 1, how to change it to 1. But if it's 0, you can change it. And of course, this condition here, put the first element in the matrix equal to 1. If it's 0, like here, if it's 0, you can't change it to 1. You can't change it. So if it's 0 or 1, it's fine. But if it's non-zero, other than 1, it's not in RREF. So here 0, it's in RREF, because you are searching, like as I said here, the third condition is satisfied. Here's the same thing, but here 1, go below and go right until you find 1. Here, go below, then keep going until you find 1. There is nothing here, so it's an RREF. The same thing, but 1 here, go below and keep going until you find 1. Go below and keep going until you find 1. Go below and keep going until you find 1. And the same thing here, 1, go below and keep going until you find 1. Go below and keep going until you find 1. And this end here, because you can't go below this matrix, because it's only 2 by 5, so you can't go below it, and I will later write the size of all of these matrices. So here, write 1 here, go below and keep going until you find 1. Okay, you find here 1, but here there is a problem below it, it's not 0, so this it's not satisfied the second condition here. So that's why it's not satisfied RREF. The same thing, put here 1, go below and keep going until you find 1. Go below and keep going until you find 1, but here there is number, so that's why it's not satisfy this one. There is no non-zero element below it when you are searching. The same thing here. You hear 1, go below it and keep going until you find 1, but this one it's not 1, that's why it's not in RREF. The same thing here, put 1, go below and keep going until you find RREF, so it's satisfied. Go below, then keep going until you find RREF, until you find leading 1. Here 3 not 1, so that's why it's not satisfied this condition. The same thing here, put 1, go below and keep going until you find 1. You find 1 here, but this one below it's not 0, because the rest of the column it should be 0, so that's why it's not satisfy this condition. So here we end here. So later I'm going to talk about what more notes and example later. And as I said, I will put the dimension here, 3 by 3 dimension, and these all 3 by 3, and here 3 by 4 dimension, here's 3 by 2. Here you can count it like this: 1, 2, 3, so 3, and you keep going to the right: 1, 2, 3, 4, 5, so here 3, 5. The same thing: 1, 2, so it should be here 2, 1, 2, 3, 4, 5, so the size is 2 multiplied by 5. Thank you for watching this video, and see you in the next video. Thank you.